Hi, everyone. We're going to be learning about how to write exponential equations or exponential functions, we should say. And here we go. And we're going to have this table here. And it says right here for number 11. I know we're starting on the back page. The table shows the number of zombies over a 3-day period. So write an exponential function to represent the number of zombies as a function of time. And so remember, the function notation is in general like f of x, right? So this is just function notation, and this is the same thing as y. Okay, so another way to say y is f of x. So it's like having an English name and a Korean name. Well, for me, it would be a Korean name, right? And so you have it's just the same person, it's the same thing, it's just a different name. It's in like a different language, right? So we have the y, and then we have function notation, which is f of x, same thing. All right, and so in this case, what we like to use, we used f of t because it was a function of time. So f of t is equal to, and so this t is basically like our x. And so, oh, I should probably also tell you, so in order to write an exponential, this is usually what we're going to see. So a times b to the t power or to the x power. And so in this case, a is that's going to be the initial amount, how much we start with. So in this case, that's going to be at time 0. So at day 0, that would be the initial amount, right? So this right here is the initial amount. Okay, that's how much we start with. And so we're going to be like, we start out with 8 zombies. If you guys remember the zombie thing that we had done before, this is that. So we start with 8 zombies, and then we're going to, and then our b, highlight that here, that's going to be our multiplier. So what you notice with exponentials, the difference with exponentials and like a linear one, with linear, we add by the same amount. This one, we're multiplying by the same amount. That's why we call it the multiplier, right? And if you notice right here, from 8 to 16, how do you get from 8 to 16? And then from 16 to 32, right? And if you were trying to add, right, 8 plus 8 would be 16. But if we add another 8, we're not going to get to 32, right? And so another way to get that, so b is equal to, you can basically take any of these two that are adjacent to each other and just divide it. So you could take 16 divided by 8, which would be 2. Or you could take 32 divided by 16, and that would also give you 2. So it's always going to be increasing by the same amount. So we're going to be multiplying by 2 every single time. So even like 32 times that by 2. So that's a times, not a decimal point, times 2. And that's going to give us the 64. So that's going to be our multiplier right here. And then we're going to do that to the t power. That's it. I know, right? And so let me just highlight a few things. So our initial amount right here, that's where it is. And let's make our multiplier, since it's growing, make that green. So that's our multiplier right here. That's that part, right? So we're going to try the same thing. And this time we're talking about dandelions. So something a little less dangerous, although maybe just as equally annoying. So again, we got dandelions over a 3-day period. And we're going to just represent this as a function of time. So initial amount right here, oh, look, we have the 0 days. So at the first day that we're at the initial time, right, that's going to be, we start out with 2 dandelions. So if we see those 2 dandelions, so f of t is equal to 2 times, and then what do we keep on multiplying by? So 2 times 3 is 6, just to verify. 6 times 3 is 18. Yep, 18 times 3 is 54, so on and so forth, right? So that our 3 is our multiplier, and then we're going to just do that to the t power. So remember, it's an exponent, so we are going to be, it's going to be smaller and up higher. Okay, so just like that. So here's our equation. And so on the first day, we have 6 dandelions. Second day, we have 18 dandelions. Third day, we have 54 dandelions. That is a lot of dandelions. All right, and that's only after 3 days, right? So again, we got rabbits, and this is over a 3-month period. So we first start out with 6 rabbits, and then after the first month is 24, and then, you know, third month we have 380. That's a lot of rabbits. All right, so again, we're going to, let's see what we're multiplying by. 6 times what is 24, right? That's going to be 4. And yeah, and then times 4. Right, 24 times 4 is going to be 96. If you did not know that, you could definitely use your calculator. And so again, in our initial amount, we do have, so at times 0, we have 6 rabbits. That's what we start with. So again, f of t is equal to 6 times 4 to the t power. All right, and please try these. Do them by yourself. You might want to go back and try it yourself to see, wait, how did Nestle get that? Right? That's always a good strategy, instead of being like, oh yeah, that makes sense, but you're not giving your brain a chance to actually process it, right? Okay, and then here, do you see right here? We don't have our initial value, right? We just have 1, 2, 3, but we don't have the 0. So we're actually going to have to do a little bit extra work here because we don't know what it is for 0. So here is our number of subscribers. So, you know, this YouTube channel, you know, after the first week, we had 960 subscribers. Okay, I don't really have 960 subscribers, but whoever this is, they did, right? So we want to know how many did they start out with, right? So we're just going to see that, okay, and I don't know how many times 960 times what is going to give me 2,880, right? So we're going to just go, so B is equal to 2880, divide that by the previous one, which is 960. Okay, and then we're going to use our calculator and go 2880, divide that by 960, right? And you get 3. You see that like correctly, or is that backwards to you? If it's backwards to you, you may want to look in the mirror. Coded message. Just kidding. So yeah, we are definitely multiplying by 3. And sometimes if I want to just check and make sure, I'm just going to go, well, 288, the 2880, I'm sorry, I keep on doing 288, and times that by 3. And sure enough, we do get 8,640. All right. So we are good to go. We know our multiplier is 3. And that means, okay, now we still need to get our initial, right? We don't know what that is. So if we're gonna like go previous to that, right? We're just gonna divide that. So if we're going down this, we're multiplying by 3. If we're going previously, we're dividing by 3, right? We're kind of undoing that multiplying by 3. So 960 divided by 3, that's gonna give us 320. So we started out with 300, or we or whoever started out with 320 subscribers. So here, let's try this again. So f of t is equal to 320 times 3 to the t power. So you see there was a little bit of extra work there, but not too much. So number 15. Notice that all of these next tables do not have a 0. We don't have the initial value. So we will have to calculate out the initial value. So please pause. Try it yourself. Right? Let's try these out. So again, I need to find the initial value. That's a 0, guys. So I'm just gonna, well, this one's a little bit easy to figure out. So 60 times 3, that's gonna give me 180. So it's not terrible. So if I go before that, I'm gonna just divide 60 divided by 3, and that would give me 20. Right, 20 times 3, 60. Yeah, we're good. So which means that we know, so f of t is equal to my initial value, which is 20 times 3 to the t. Here, again, we don't have our initial value, so we're going to go with, this one's pretty easy. 12 times 2 is 24. So this is just times 2. Again, if you don't remember that, you're like, oh, I'm not good with my multiplication. You can always just figure it out this way. Remember, 24 divided by 12, put that in your calculator, and you're going to get 2, and that would be your multiplier. And I always just check it, 24 times 2, does that give me 48? Yeah, because sometimes we can put it in the calculator wrong, right? And then, so if we go 12 divided by 2, that's going to give you this number right here, which is just 6. And so it's going to be f of t is equal to our initial value, which is 6. So we first start out with 6, and then what do we keep on multiplying by? We're multiplying by 2. So 2 to the t power. So if this inside the parentheses is t, then our variable over on the right-hand side is going to be t. If this variable is x, then our exponent is going to be x. Okay, they are going to always be the same. All right, last two problems. Again, we need our initial value here. Okay, this one I'm not exactly too sure like what that's going to be. So I'm going to find out my b first. So it's going to be 192. Divide that by 48. And that's going to be 1, 2, 3, 4, probably 4. So 192 divided by 48. And your multiplier doesn't always have to be a whole number, but for us in this case, in these cases, since it was just an introduction, they're going to be whole numbers. And sure enough, that is a 4. So here, we're going to write down 4. So we are multiplying by 4 every time. So in order to get the initial, it's going to be 48 divided by 4 because we're going backwards. So that's going to be 12. So f of t is equal to, excuse me, is equal to 12, our initial, times 4 to the t. And then our last one, 0. And this is going to be times by 3, right? Because 3 times 21 is 63. And so dividing 21 divided by 3, and that will give you a 7. So our initial value is 7 times that by 3 to the t power. And that's it. Easy days. Good luck. Bye.